inverse trig functions is what 3.9 is. We have to use that TV, so if you want to turn your chair, we're using this TV. Inverse functions we have done before. So we know an inverse is like the switch of the x and y, right? Like if I have coordinate points, we switch the x and the y. If I have an equation, we switch the x and the y, we solve it. Okay, if I'm looking at a chart, I switch the x and the y. If I'm talking about domain and range, I switch domain and range. Like all of that switches for inverse functions. Now we're talking about specifically inverse trig functions. So what happens when we look at the inverses of our sine, cosine, and tangent functions? That's the idea behind this section. So the way you will see inverse for trig functions is two-way. Like if I had f of x, for example, like we did f of x, and I asked you what the inverse of f of x is, you would put f negative 1 of x. That's how we showed inverse of f. But when we're talking about trig functions, you can either see it that way. So the inverse of sine is sine negative 1. The inverse of cosine is cosine negative 1. The inverse of tangent is tan negative 1. Or you will see the words arc put before it. Arc, cosine, arc, tangent, arc, sine are the same as the inverse. Okay? These will literally be used interchangeably. So in a question, you might get the word arc sine, or in a question, you might get the word sine negative 1, and you have to know those mean the same thing. They both mean inverse of sine. If you are finding a specific angle, like so let's say it's using unit circle base values, it could say find tan negative 1 of 1, and what it's saying is give me the angle where your tangent is 1. All right, so it would be the same if it said arc tan, if it said arc tan, okay, of 1. It would be asking where is your tangent 1, okay? And the answer is pi over 4, okay? If it gives you an interval, like it could say from 0 to pi, what is arc tan negative 1? And now it's saying from 0 to pi, so just the top part of your graph, where is tan negative 1? And that answer would be 3 pi over 4. It could also ask about sine and cosine. So this is where the memorization of having your points obviously helps you, okay? If it said arc sine 1/2, you're looking for where your y is positive 1/2. What happens at the over 3? No, it happens at the over 6s, sorry. And if it was positive, so that would be pi over 6. So that's some of the questions will ask you just flat out that stuff. So for example, sine negative 1 of root 2 over 2. Where does that happen? Pi over 4. Good. 2 cosine negative 1.
But wouldn't that be...
So if it doesn't give you an interval, we assume only first quadrant.
Even though it's negative?
It's not negative. This is negative, but the root 2 over 2 is positive.
Oh, I'm on the wrong side.
Yeah. All right. 2 cosine negative 1 root 3 over 2 is pi over 6. 3 arc tan of 0. 0. And then we get sine negative 1 of 0.25. So 0.25 is like a fourth. Is a fourth on your unit circle? No, this is where a calculator would come into play. So we hit inverse sine, we put 0.25, and we make sure we're in radians because we answer all of these in radians, and everything on your test is in radians. So I second sine 0.25, and we get 0.2526. So 0.253, and again, it should be in radians. Sure. All right, then we bring in the graphs of sine, cosine, and tangents inverses. In my opinion, there's two ways to look at this. One is literally take your graph and flip it, but the other way is to kind of memorize these shapes. And I think it's easier if you can memorize these three shapes, okay? So if I didn't know what the inverse sine function looked like, first of all, we have to restrict it. We can't say our whole sine curve, because our whole sine curve, which looks like this, okay, is going to continue on forever in both directions, right? And in order to find an inverse, do you remember what the test is to see if something has an inverse? If it's invertible or if it's one-to-one, do you remember what it is? Vertical is if it's a function, so horizontal is if it has an inverse. If I take my original sine curve and I put a horizontal line through it, is it going to pass? No, it's going to fail, so it wouldn't have an inverse. So what we do is we have to restrict sine to just one part of the curve so that it does have an inverse, okay? We need that part of the curve to have both positive and negative values of sine, and we need it to be one fluid part of the curve. So for sine, like I can't take this part of sine and then this part of sine because that's not a continuous curve. So for sine, we take from negative pi over 2 to positive pi over 2. This is the part of the curve we restrict it to in order to find its inverse. You with me so far? So you have to restrict the initial one, otherwise it doesn't pass your horizontal line test and then it can't have an inverse. The way we restrict sine is from negative pi over 2 to positive pi over 2. Now that's our original sine curve. So if I wanted to take these points and find the inverse of this sine curve, I flip all those x and y's, right? This coordinate point is negative pi over 2 and negative 1. This coordinate point is 0, 0. And this coordinate point is pi over 2 and 1. That's the original sine curve. So if I want to find the inverse to sine, I'm going to switch all those coordinate points. So that the inverse of sine, negative 1, would have the coordinate points that are negative 1, negative pi over 2, 0, 0 doesn't change, and then 1 pi over 2. So if you completely forget what these curves look like, you can go through that process. But the other way to do it is just kind of memorize these coordinate points. So the negative 1, negative pi over 2 is there. 0, 0 is here, and 1 pi over 2 is here. And it takes on like this almost side, it's almost like half of a, like an hourglass, if you want to picture it that way. Kind of like an S curve, okay? But it dips below the x-axis and comes above the x-axis. So it goes, notice that the y-axis is now your angles, and the x-axis is now your constants, because we switched them. So if you think about those characteristics, our domain goes from negative 1 to 1, because that's our x values, and our range goes from negative pi over 2 to positive pi over 2. The original sine curve is the reverse of that. The original sine curve, our domain is negative pi over 2 to positive pi over 2, and our range is negative 1 to 1. You with me so far? Okay, so now let's talk about doing the same thing with cosine. With cosine, your parent function looks like this. Well, technically it would keep going, right, in both directions. It would fail your horizontal line test if you use the whole thing. But I also can't restrict it the same way I did for sine, because this is negative pi over 2 to positive pi over 2, because this part of my curve would fail my horizontal line test. So we restrict it differently. We restrict it from 0 to pi. So this part of your curve, I need positive and negative values on the y, which I have, and I need it to be one fluid part, one continuous section. So for these coordinate points, I'd have 0, 1. I'd have 0, 0. That's this point. And then I'd have pi. No, not 0, 0, sorry. I'd have pi over 2, 0. And I'd have pi negative 1. So those would be on my original cosine curve. Now I flip them to get my inverse. 1, 0. 0 pi over 2, and negative 1 pi. These would be cosine negative 1 points. So if you look at the graph, 1, 0, 0 pi over 2, negative 1 pi. So this is the flipped version kind of your sine curve, and it all stays above the x-axis. So my curve goes from negative 1 to 1 above the x-axis for cosine. And then the last one is tangent. well, here, actually, sorry, let me talk about domain and range. So on this curve, my domain left to right, -1 to 1, my range 0 to pi, which is the switch or the inverse of my initial cosine curve. Okay, then we get to the tangent function. And our tangent function has a vertical asymptote at pi over 2. I mean, at 0 and pi over 2. And it looks like this in between, okay? That is how we restrict. We just grab one curve, okay? So it goes from negative pi over 2 to positive pi over 2. This time we don't include those points because there's an asymptote on the pi over 2 and the negative pi over 2. But those coordinate points are going to switch. So I have 0, 0 in the middle. A quarter the way in and 3/4 the way in are where your -1 and your +1 are. So, well, this is pi over 4, 0 would be that coordinate point, okay? And then pi over 8, because a quarter the way in, -1, and 3 pi over 8, 1 is the other one. If you take those and flip them, tangent's the easiest one to remember. They will turn this way. So it's going to cross through 0, 0. It's like a cubic function turned on its side, okay? Or almost like a cube root function. Turned on its side. These don't end. Those arrows would continue to go, whereas sine and cosine both start and stop. So the range of tangent is negative pi over 2, positive pi over 2, because there would be an asymptote here, and there would be an asymptote here. And the domain is all real numbers because those arrows point left and right. So a chord like I don't want you to stress about it too much. You don't have to have those memorized because tangent you can kind of just know to turn it. Like I feel like sine and cosine people confuse those two curves. So I would definitely make sure you knew the backup with that with the switching of the points. But with tangent, you just take your curve and you kind of just turn it. But these points, like you have on your natural tangent, you've got a asymptote at 0. And you have an asymptote at pi over 2. So the midway point is where your x-intercept is. Halfway between 0 and pi over 2 would be pi over 4. And then a quarter the way in, or half the distance between 0 and pi over 4, is where your -1 is, which would be pi over 8. And then halfway between pi over 4 and pi over 2 is 3 pi over 8. And that's where your -1 and your +1 go. I don't know that you need to memorize the pi over 8 and the 3 pi over 8 as long as you understand what happens when you turn it. Yeah. But you can. Okay, so now we have to talk about the restricted domains on our unit circle. So we've got restricted domains on our curves and restricted domains on our unit circle. They are the same restrictions, but obviously they look different when you plot them this way. If you are asked to find sine -1 of -1/2, let's say, and you use your full unit circle, if there's no restriction, how many answers are there? 2. But, which is fine if it says sine of x equals -1/2, what are the angles, and you can have plural answers there, to give you that value. But if it is inverse, there is only one right answer there, and it comes from the same restricted part as our curves. So sine and tangent, we restrict from negative pi over 2 to positive pi over 2. We did it on the last curve. Why? We had to cut it so that it would pass my horizontal line test. I need positive and negative values of sine and positive and negative values of tangent. And cosine, we went from 0 to pi. So we use the natural top of our graph.
Why don't we use quadrant?
Because you need it to be positive and negative versions of both. So like cosine, I need the positive and negative x values. But I can only go one curve because I need it to pass my horizontal line test. So, yeah, okay. I was going to say we talked about it when you were in the restroom. Yes.
You have written both quadrant, right?
Sine and tangent. So sine and tangent we go, because look at these angles. These are negative angles. So we go negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, then 0, then your natural quadrant 1. So if I now said, you have to know what it's restricted to, and if I now said sine negative 1 of negative 1/2, what's the answer? Where is the y negative 1/2 from the restricted part of sine? Negative pi over 6. And that is the only correct answer. If you give 11 pi over 6, it's wrong. And if you give, what's the other one? 7 pi over 6, it's wrong. So you have to know which areas to restrict it to. All right, so now think those restricted areas. It would be sine and tangent on the right. It would be cosine on the top. So what's the answer to sine negative 1? Negative root 2 over 2. Negative pi over 4. What's the answer to cosine negative 1 of negative root 3 over 2?
Negative pi over 6.
Not negative. Cosine's the top. So cosine's angles will never be negative. 5 pi over 6. Arc tan negative 1. Where would we pull the negative tans from?
The third one, negative pi
Fourth quadrant, the negative angles. So
pi over 2.
almost. Where's tan negative 1?
3 pi over 2.
Nope. Yep. Negative pi over 4. Tan. Sine negative 1.
0.
Negative pi over 2. It's the bottom, right? Which we call negative pi over 2. We can't call it 3 pi over 2. It would be 3 pi over 2, but we have to restrict it to negative pi over 2 to positive pi over 2. So we pull the negative pi over 2. So when you're answering inverse cosine, and inverse cosine, you use the whole regular top, like natural. But inverse tan or inverse sine, you take the fourth quadrant and the first quadrant, but you use the negative angle names for the fourth quadrant. Because it had to be fluid. So it had to go from negative pi over 2 to positive pi over 2. If you were to use from 0 to pi over 2, let's say, and then you skip pi, you skip 3 pi, and you go to 3 pi and 2 pi, now you're over here. And that is not one fluid part of the curve. So we have to use this part. Does that make sense? Okay. All right, now let's talk translations and dilations on those inverse functions. It's going to ask you to do all the same things that we did with sine and cosine, but using your inverse function. And this is where it comes in handy to memorize what they look like, okay? So A still causes the vertical dilation, B horizontal dilation, C phase shift, D vertical shift. A and D are going to affect the range of your function because A and D affect the vertical. And B and C will affect the domain of your function. That one's spelled wrong. Because those will affect, affects the vertical stuff, which is range, and this affects the horizontal stuff. The difference is it's going to put a negative 1 on these things now. So now you're talking about the inverse functions. So cosine stays above your axis. Oops, 1. That's a 1. Like that. This is cosine negative 1. And sine dips below. Because sine goes from negative pi over 2 to positive pi over 2. And cosine goes from 0 to pi. So the vertical axis matches what we restrict the angles to. And the horizontal axis is always going to go negative 1 to 1 because it's sine or cosine. So memorize these graphs makes life a lot easier because now we can stretch, shrink, shift them around. We're going to draw it again one more time on the next one. All right, so it says describe the transformations on the graph of the inverse cosine sine function. Find the domain and range of the inverse, then graph the transformed graph, okay? First of all, talk about the transformations. The 1/2 on the front is doing what? Vertical dilation by a factor of? Good. No other transformations, right? So now think about what our parent function of cosine -1 looks like. It starts left and goes right. It goes from -1 to +1. And it's like a reverse curve like that. It passes through 0 pi over 2. So cosine stays above the x-axis. Now, if I wanted to adjust all those y values by a half, I literally multiply all the y values by a half. So pi times a half would be a half pi. Pi over 2 times a half would be pi over 4. And 0 times a half is 0. So my stretched vertically, compressed vertically, would look like that. Now, what's the domain of that function? -1 to 1. What's the range of that function?
0 to pi over 2.
Good. You can either get it from your graph, or you could take your original domain and range. The original domain and range of cosine -1 are -1 to 1 and 0 to pi. And you can multiply the range, because the range would be the y's, by a half. So you want to be able to do this visually, describe it in words, and also adjust your domain and range without having to see it. Okay, go to sign. The +1 inside the parentheses, what's that doing? Left 1. The minus pi over 2 outside the parentheses? Down pi over 2. Good. So the inside's going to impact my domain because it's horizontal. The outside's going to impact my range because it's vertical, right? Okay. So now our initial sine curve starts under the curve from -pi over 2 to +pi over 2. And it does like an hourglassy shape that way. Well, no, it doesn't. It goes this way. Sorry. Yeah. Unless there's a vertical, unless, you mean the initial one? Yeah, parent goes from -1 pi to 1, 0. Yep. Okay, so now let's do all the shifts, okay? We're going to go shift left 1. So all these points go left 1, left 1, left 1. It would look like this. And then we want to shift down pi over 2. So I want to go down pi over 2, down pi over 2, down pi over 2, and there's the ending curve. Now from your graph, read your domain. What's your domain from the graph? Good. And what's the range? Good. Now think about your domain and range from your equation. My parent function of sine, the domain goes from -pi over 2, sine -1, sorry, to +pi over 2, and the range goes from -1 to 1. So if I wanted to adjust it using that equation, the left 1 would affect my domain. I would subtract. Did I do that wrong? Yes, I switched that. Sorry, I switched it. The domain is on the inverse is -1 to 1, and the range is -pi over 2 to +pi over 2. So if I wanted to shift my domain -1, I'd get 0. No, I'd get -2, 0, which matches what we found. And if I wanted to adjust the range down pi over 2, I'd subtract pi over 2. And I'd end up with -pi, 0. So you want to be able to do it both ways. Questions? All right. Now we're going through the inverse using equations. So find your inverse using the equation means switch the x and the y, right? Solve for the new y, and then make it the negative inverse, like on the f. So I'm going to take, first of all, I'm not worried about this restriction. It's restricting it so that it can be, the inverse can be found. Don't worry about it. It's not going to ask you to find that restriction. So f of x equals 2 tan x over 3. First thing I'm going to do is, this would be my y. I'm going to switch my x and my y. So x equals 2 tan x over 3. Y over 3. Y over 3. Now I want to solve for that new y. So I want to isolate the y. What's the first thing you're going to do?
Divide by 2.
Divide both sides by 2. So it'd be 1/2 x, or x over 2, equals tan y over 3. Now if I want to undo a tan, right, what do you do?
Inverse of tan.
Good. Inverse. So tan -1 both sides of your equation. And I get tan -1, 1/2 x, or x over 2, same thing, equals, these are going to cancel, y over 3. And then, how do I get rid of the over 3? Multiply by 3. So f -1 of x, because you have to note that it is now the inverse, equals 3 tan -1 of 1/2 x.
Could you do x over 2?
Yeah. You'll see it one way or the other if it was multiple choice. If it's open-ended, both are fine. If it's a multiple choice, obviously, it will be one way or the other. Usually it's the 1/2, I think, but not always. All right, go to B. So what are we going to do first? Good. Make the f of x, y, switch it. So it's x equals 3 sine 2y. Then I got to isolate the sign, so I'm going to divide both sides by 3. Let's leave it as x over 3 this time because it doesn't matter. Just so you see it both ways. The opposite of sine is, or the inverse of sine is, sine -1. So I have sine -1 x over 3 equals, these cancel, 2y. And then divide by 2. This time I will tell you they typically push that to the front. So this would be 1/2 sine -1 x over 3. If it was open-ended, and as long as that whole thing is over 2, I'd leave it. I'd give you the credit. Those are equivalent. But most likely, if it's multiple, well, not most likely. If it's multiple choice, the 1/2 would be at the front. So just make sure you know it's the same thing. Questions? Okay. Last slide says write A as a function of x. So we're back to the triangles. Okay. So what they're trying to do is basically solve for A. Okay. So we're writing it. You're not solving it because you're just writing it in terms of the other one. Okay. If I'm using A as the angle and the two sides I have are 10 and x, 10 would be where in respect to the A? Opposite. The x is adjacent. So which trig function are you going to use? What uses opposite and adjacent? Tan. So I can say tan of A equals 10 over x. But I want to write it in terms of x. So it would be tan -1. No, I want to write it in terms of A. Tan -1 of 10 over x would equal A. That's what it's looking for. Just solve for the angle.
That's it?
Yeah. If there were a value there, you could find it, but these questions will literally, like there's an AP question that's literally asked you just to write it in terms of it. That's it? Mm-mm. You have two unknowns there, so you would need one more. Yeah. Questions? All right, so tonight, obviously, you're doing the last PDF and AP Classroom. Tomorrow, we have a lot of AP Classrooms to go over. Okay, we'll talk about your test, and then we'll start the review, and then we'll also go back through your AP Classroom, because I don't think we went over 6, 7, right? Or 8. So we've got a lot of questions.